Hello everybody and welcome to my channel. This is Sohini from South Bay, California, and I welcome you today. For anyone who's new to my channel, this is where we talk about anything AI. And today I am super excited to bring to you this version of AI concepts and tools. Today's session is for anybody who has some working knowledge on Python, but you would like to get more hands-on experience on coding on ML or machine learning libraries. If this is of interest to you, please thumbs up and subscribe to this channel. And please leave me a comment if you would like me to cover more such softwares for beginners into machine learning. So let's get started. So technology has developed so much that in order for us to learn a new language such as Python, we don't really need the software to be installed on our computers anymore. All you need is a strong internet connection, something like a Google account, and a web browser. So if you're using Chrome, Mozilla, or Microsoft Edge, or whatever be your browser of choice, you can start coding in Python and get started on the machine learning and deep learning libraries. So today I will be showing you the steps you need in order for you to get introduced to the machine learning libraries in Python using just your web browser. All you need to do is, again, make sure you have a strong internet connection, and you should also have a Google account so that you have a Google Drive. So ensure that you have access to a Google Drive where you can download the two files that I will be showing and linking in the description box below, and then you can clone the Google Colab codebook and start coding on your own. I will also be putting links in the end as to what are some extensions that you can do in order to start coding in Python. Okay, so here is how we get started with today's lesson. So we will be starting with these two files that I'm going to be sharing. So this link for the Google Drive I will be sharing in the description box below, and you will see that there are two different files in it. One is the codebook and the other one is the data. This data is taken from Kaggle set already, but I have trimmed it down in order for it to represent only the data that we need for today. So this is what you need to do. You will need to double click on this codebook, and you will see automatically it says open with Google Collaboratory, and that is exactly what you will do. So what it will do is, you will open up this code corresponding to your Gmail account in your own Google Colab. What you should do at that point is, you need to do a file, and you can either just save a copy in your drive because you've already connected to your Google Drive. You can just, for my case, it's already in my Google Drive, or you can also just download it as an IPython notebook and upload it in your own Google Drive, right? All right, so let's look at each and every cell. So every single code cell is actually called as it's a code cell. So there are these text cells, and then there are these code cells. And if you want to enter your own, you can just hit a plus code, and then a new cell will open up, and then you can enter code in it. So the first step we will need to do is, in order for you to authenticate that you have access your Google Drive and then share data from there. So in order to run every single cell, you need to hit Shift and Enter. So Shift and Enter, and then you again hit Shift and Enter, and whenever this particular Python notebook is running, this is how it will appear. And as soon as it's done, a number will pop in next to it. Now for authentication, it will say go and hit a particular link. You need to then go and give it access that yes, Colab can access your Google Drive. So this particular code will appear. You copy this code and you paste this particular code here. So for your system, your Google Drive, you will get a different code. So this authentication has to happen. Now you will need to pass a file ID. You see this file ID that needs to be added. Now how do you find this file ID? Remember I told you in the beginning, you need to copy these two files in your Google Drive. Now if you go to this particular file and if you say share, you will see if the copy link appears. And now if you go here and if you just paste it, so this you see this file ID, this 1ky something something comes up, and then there is the sharing in the end. You will just need to copy this part, this number part, and paste it right here. Okay, you need to remove everything else. So this is just the file identifier in your Google Drive, and this is the name for that particular file, right? So you just hit Shift Enter, and this should be able to, so now you've already authenticated your Google Drive, and now you've also given the file ID or the handler in order to access this particular file that your Colab is trying to read. Okay, so now you have everything in order to start working on this particular data. So now that we have read the data, we need to use the Pandas framework. So Pandas and NumPy put together is extremely powerful for data wrangling, which is, you know, working with data streams like an Excel sheet, you know, can read. So what we do is we import the Pandas framework, and now we have the data set, the CSV file, and we just read it, and here we're just displaying it. So you see it's this data.head command will do that, and you're just seeing all the different columns. So these are different dates, and these are the countries, so the latitude and the longitude, and the number of infections on that particular day. That is, you know, what this table represents. So the original data, what we'd like to know is what's the dimension. So you see the shape of the original data is 266 by 225. That means there are 266 rows, and then there are 225 columns in this whole data set, right? However, we don't need to retain all of them. You see, like the first column is nan, so it's generally not usable. So you need to discard, you know, the columns that you don't need. Again, the country name, again, you don't really need it. So you can actually discard them. So let's do a little bit of pre-processing, and also let's club off, you know, the cut off the data so that we only use the portions that, you know, we require. So we're starting from the step number 3 in order to cut off the data so that we have only 50 rows and 100 columns, right? So we do Shift Enter, and now you see my data has 50 rows and, you know, 100 columns. And let's look at and view that this data is correct or not. And you see this is only the dates, right? So only the number of infections. I'm not using the rows and the columns or the latitude and the longitudes here. I'm just trying to visualize, has my data been correctly read or not. You see, initially you have only 0 values, and then all of a sudden the numbers start popping up, and then they become actually huge going towards the end. Now, let's find date indices, because here, if you see, the data is not structured in a way for you to do a standard machine learning. In standard machine learning, you always need data in this particular format, that you have X, which is corresponding to the features that are of interest, and Y is the label. In this case, it's the number of infection. So ideally, you want to convert this data into the format that you have a longitude, you have a latitude, and the date. So these are the 3 features, X1, X2, and X3. And your Y is the number of infections that you want to predict or track, right, for your test data. So we need to convert this table data into this particular format in which it'll be, you know, X1, X2, X3, and Y. So this is an example of data wrangling or data pre-processing, in which you take any data, but then you are able to format it in the format that is of interest to you. So let's do some data wrangling. All right, so now we are going to be formatting this data. And you see now we have the days corresponding to it. And now let's convert it finally to this X1, X2, X3 form that I just talked about, where you have X1 is the latitude, X2 is the longitude, X3 is the date, and you have Y is the number of infected people. So now let's check if the shape of X is correct or not. So remember, you had you know, 50 rows and 100 columns, but now you have you know, essentially you have made everything as a row. So you have 5,000 entry points, and every single data has, you know, 3 columns, which is your latitude, longitude, and the date, and the Y is the number of people who are infected. So this is how you do data wrangling. And again, so now once that you have the data preparation is done, next what you need to do is you need to plot that if the data is correct or not. So let's do a scatter plot. And this is how your scatter plot looks like. So it's the number of days that has elapsed since January 22nd, and this is the number of infected you know, people, and this is what the graph looks like, right? So it's a pretty big graph, and if you see, most of the infections are around, you know, the lower sides, but however, some of the countries are showing much higher rates, starting from the top. So now what we are interested to do is we are interested to fit a regression model for the days versus the number of infections. And here, as a first rule of thumb, we apply the machine learning concept of train test split. What that means is we take 70% of the data randomly and we use that for training, and 30% of the data we keep it for testing so that we can figure out how good a model we've actually fit in this case. Now you have 70% of the data which is passed to xtrain1, and remaining 30% is passed to xtest1, right? And these are the labels ytrain1, ytrain and ytest. Now what we are interested in doing is, if you see this regression, this is not, it is linear regression, but if you see the line is actually curving up, so it's not a straight line that you want to fit, but it's more like a curved line. So this seems like a very good use case for polynomial regression, and that's what we are trying to fit in here. So we are going to be using the scikit-learn, and we are going to be using polynomial features. So what the polynomial feature does is it will first take the features that we have, that is x1, x2, x3, and what it is going to do is it's going to extrapolate more features from there. So let's consider for our case, we have x1, which is my latitude, x2, which is my longitude, and x3, which is my date. And if I want to fit third order polynomials, then I actually end up with 20 different parameters. Now, why are there 20 different parameters? I will leave that math to you, and if you have questions, you can ask me in the comments and I can comment on how you actually get to number 20. But think of it this way: the number of parameters you would need is, for x1 you would need x1 cube, x2 cube, x3 cube, then you'll have x1 squared x2, x2 squared x3, x3 squared x1. Of course, you have x1, x2, x3, and then you have x1 squared, x2 squared, x3 squared. So these are all the different permutation combinations of getting to a polynomial of degree 3. So the first thing we need to do is we need to pass this polynomial features for the training and the test data. So that's what we are doing. We are fitting this transform. So essentially what we are doing is, and I'll show you what the size of the data is. So new shape of the test data. And you'll see now the test data, you've moved it from 3 dimensions to 20 dimensions, which is just the squared and cubed and all formats of the same data. So if I just run this, now you see the shape of the new data is 1500. So you have 1500 rows for your test data, and the number of columns is 20 as opposed to 3 features that you had sorted. And this is because of the polynomial features. And then I'm just passing it through linear regression, and I'm doing a model fitting. So I'm model fitting on the training data using the ytrain. All right, and here I'm just printing out the 20 different coefficients and the constant coefficient value for the trained model. Finally, I need to predict. So like I said, I did an initial 70-30 split. I've trained the data on 70%, but I need to test, is it any good or not? So that's what I am actually going to be testing it out on the test data. So here all the black points are actually corresponding to training data, and the blue points are corresponding to the test data that you have just predicted. So if you see your prediction, because it's a polynomial prediction, it's not just covering the linear lines, but it is also able to cover some of the, or predict some of the points which is going, which is curving out. So it is as good as a polynomial prediction that you can do in this case. And you can also predict the mean squared error in this case between the test and the prediction value. And this is, of course, it's a high prediction value because these numbers are not normalized. Ideally, if you had normalized the numbers, you would have gotten a number between 0 and 1. The last thing that I wanted to show you is 1D polynomial regression. So of course, in this case, what you were doing is you were predicting the values, for a test case. However, you must have seen for regression, there is always a points and then you fit this linear line around it. How would you go about doing that in this case? So that is called your poly 1D. So of course, you're doing the same thing as you're doing your poly fit, but along with that, you are then fitting a 1D polynomial along the dimensions of the data which is of interest to you. So in this case, your x scale is ranging between 0 and 100, right? So you want to make a polynomial with a 1D parameter, which is your 0 to 100, and that is the x dimension or line space of your polynomial fit. So if I just run this particular box, you will see now you have your blue dots is your corresponding to the actual data, and this red line is showing you your your model fit. So, and this model fit complexity you can actually change. So in this case, you see this was a polyfit of order 5. I can change this to polyfit of order 3, and you will see that the curve is actually changed. And again, if you want a polynomial fit of order 1, you will actually get a linear line fit. You see, this is a straight line, and as you increase the polynomial fit, the polynomial order, you will see that your line starts to curve more and more. So you see, this is more of a curved line than a straight line. So there you have it. This is an example of how you would fit regression into infection testing and analysis data set. Let me know if this is of interest to you and if I should be covering more. Finally, I wanted to show you another example of linear regression. So, and again, I will be sharing all of these links in the description box below. But this is another example of people with diabetes. And again, this is just showing you the graph, but what I wanted you to do is, if you just wanted to start, is you just go to the bottom and you say launch binder. So binder is another way in which you can actually launch Jupyter notebooks, or these Python notebooks from your Explorer, or Google Chrome, or whatever browser that you're using. It does not require any requirements on your PC at all, and this is pretty functional and fully capable for you to at least get hands-on experience working on Python, just having nothing than a browser. So what it'll do is it'll open an IPython notebook that looks very realistic to a IPython environment, and this is and you can even try a lot more codes right here. So after you're done with this, I would motivate you to try the other ones out, but this is trying ordered least squared. So you just again do shift enter, and you will see that it is automatically creating this module, and you see this plot got created. So the coefficients are here, the mean squared error is here. Quickly going over this data set, it does the same thing. It automatically loads the data set first, then you're splitting the data into training and test, and then you're only using very limited number of columns. In this case, only one column is being used for the particular data, and then you're fitting your linear regression models. And then you're doing the predict value, just like I mentioned, and the mean squared value is being computed along with the R-squared statistic. So this is a good example, and once you're done with this, I would say go step through the other codes, load them, launch them, and enjoy working on Python and machine learning through just your browser. So if you're interested in more, please leave me a comment, and I'd love to cover more topics for you as well.